Assalamualaikum warahmatullahi wabarakatuh. So in this video, we are going to do our presentation on the engineering survey group project, which the main target is to produce an urban 3D plan by using integration of UAV orthophoto and terrestrial laser scanner. So this group is led by one Ahmad Shamil, and the another three group members is me, Muhammad Zakan Hafiz, Nur Faizah, and also Devendran. So in this project, we chose to do it at the area of T06 UTM with a radius of 1 to 2 kilometer. Also in this project, there is some definition that is need to discuss, which the first one is three-dimensional mapping, or commonly used 3D mapping lah. So 3D mapping is act of mapping an object, structure or area and describing it in the form of X, Y and Z coordinate, which also known as a point cloud. So this point cloud is a collection of data points defined by the given coordinate system. So the next one is terrestrial laser scanner. Terrestrial laser scanner is a contact-free measuring device which can collect the point cloud of object or can collect the coordinate of object, and it will process the coordinate, color and reflectance value of the object. So the last one is unmanned air vehicle, or commonly known as UAV. So UAV is a inhabited reusable motorized vehicle that is flying vertically above the object in a few meters in order to collect the data for the production of the orthophoto. Or we can say that UAV is used to take the picture of the area.
Development of technology. Here we will discuss how technology can help in urban 3D planning process. Number one is through the internet. Through the internet, urban planners can design cities that are remote worker friendly. Number two is cloud technology. Cloud technology can help in planning larger infrastructure projects such as unmanned aerial vehicle UAV. Number three is ground-based technology. Terrestrial laser scanning or TLS is a ground-based active imaging method. Number four is Internet of Things. Many of the basic IoT tools are already in use. Those include smart street light that switch off automatically and save energy. Number five is planning apps. Urban planners can use modern technology planning tools such as ArcShelf, MetaShape, and architecture and building design tool assist in the urban design process. So we will take a look to this technology, which is cloud technology and ground-based technology. Cloud technology is unmanned aerial vehicle or UAV. Integrating UAV with the cloud makes the UAV a part of the cloud. As a result, the cloud infrastructure is composed of the powerful servers provided by the cloud for service and computation as well as UAV being served, offering resource and service to interact with the physical world. Next is terrestrial laser scanner or TLS. As a ground-based technology, terrestrial laser scanning or TLS is a ground-based active imaging method that rapidly accurate dense 3D point clouds of object surface by laser range finding. It's suitable for measurement of building height.
So let's talk about the objectives of the project. When modeling a virtual 3D city model with 100 or 1000 of buildings interactively, it will take an enormous time and labor to create them. When creating virtual 3D city model or urban planning or facilitating public involvement, virtual 3D model should covers a lot of citizens and stakeholder building involved. The base map, which is urban 3D plan as a source for these virtual 3D city models, is expected to be the digital map for urban planning that are stored and administrated by GIS. So the objective of this project is to produce an urban 3D plan of T06 UTM by using UAV orthophoto and terrestrial laser scanner.
For the theory and concept, urban designing is a concept which more focus on the shape, surface, and the physical features of all kind of the urban element, such as the building. So, much detail and multi-dimensional is needed to produce this urban map. This map is widely used by all the people in the world, directly and indirectly. So nowadays, many platform has been using these maps such as Google Map and also Google Earth. High technology device is used to create this design, like UAV and also terrestrial laser scanning. So in the UAV, a digital calibrated and integrated camera is installed to obtain a high resolution aerial image. This is to make sure that the final picture will be sharp, and the UAV also will fly at a low altitude to make sure the picture taken is in a accurate radar. The usage of terrestrial laser scanner is to acquire a complex geometric data from the building faster and easier. Besides, the intensity of the returning signal can also be obtained by using this device.
There are two instruments or hardware used to produce urban 3D plan. First instrument is an unmanned aerial vehicle, or we call it UAV. UAV is an aircraft without a human pilot on board and a type of unmanned vehicle. UAVs are a component of an unmanned aircraft system (UAS), which include a UAV, a ground-based controller, and a system of communication between the two. The flight of UAV may operate with various degrees of autonomy, either under remote control by a human operator or autonomously by onboard computers. Next, second instrument is terrestrial laser scanner. Terrestrial laser scanners are used for detailed three-dimensional data acquisition of objects. This is a very fast and cheap way to produce 3D models. Terrestrial laser scanners have application in many different areas such as deformation measurements, quality control, or cultural heritage monitoring. In this project, there are some software involved and used for UAV and terrestrial laser scanner. First, for UAV is Agisoft Metashape. Metashape allows generation of dense point clouds, texture polygonal models, georeference through automosites, and digital surface model (DSM) or digital terrain model (DTM) from area and ground still images. Powerful and cost-efficient, Agisoft Metashape is a multi-tool, easy-to-use software for professionals of the photogrammetry industry. Then, for terrestrial laser scanner, is the Riscan Pro software is being used. Riscan Pro is the companion software for regional terrestrial 3D laser scanner system. Riscan Pro is project-oriented. The entire data acquired during the measurement campaign are organized and stored in Riscan Pro project structures. This data includes scans, fine scans, digital images, GPS data, coordinates of control points and type points, and all transformation matrices necessary to transform the data of multiple scans into a common well-defined coordinate system.
Type of data. Type of data that we collected from UAV and TLS. From UAV, we can simulate three-dimensional landscape and extract related information or data. Number 2 is produce an orthophoto. Number 3 is irregular settlement with high density housing. From TLS, which is terrestrial laser scanning, we essentially result in a density of cloud point where each point has the coordinates x, y, and z. Number 2, the principal component in distance measurement device able to create 3D model of object of a wide range of size and shape.
Now I will explain about the methodology for the project.
In the first phase of methodology, it consists of literature review of the study to identify the issue and problems related to the research. Literature review is a very important part, especially to study the fundamental of the study regarding the research. Literature review will be related towards the problem statement. In this study, combining the point clouds from both methods is the issue as involve lot of point clouds. Some studies have been done to identify the solution. The review is to gain knowledge, acquire more information and understanding regarding the scope of study. In this phase, data collection was carried out by using the UAV and the GLS 2000. First thing that were done are recognizing the study area and determining the flight line according to the suitable situation. DJI Inspire 1 was used to obtain the aerial images. Meanwhile, Topcon GLS 2000 was used to collect the ground data. The flow chart of data acquisition, which are divided into three parts: establishment of ground control points, aerial data collection, and ground data collection. Ground control points are points on the ground with known coordinates in the spatial coordinate system. For GCP in this study, it was established by GPS observation. Rapid static method was used. The satellite was observed using Topcon GRF5 approximately 20 minutes. In this research, GCP is determined prior to the UAV and GLS data collection because in this process the coordinate obtained will be used GLS data collection. All coordinates will be in WGS84 system. The GCP was set up on a point plan prior to the GPS observation. About 6 points were established for laser scanner points, meanwhile about 5 points established for UAV's GCPs. In this process, UAV was flown over the study area to get theoretical view of the building and subsequently to obtain the images of rooftop for the study area. Few aerial photographs will be taken by the UAV that will further used to generate orthophoto point clouds. For aerial data acquisition process, a rotary UAV platform DJI Inspire 1 model was used for whole data acquisition to acquire image from the study area due to its ability and safety where the symmetrical position of the rotor helped the UAV to maintain its planar angle. It is also important to plan the flight before flying as it is one of important aspects in aerial mapping. Flight planning includes weather and ground condition and time frame of photography. Mission must be carefully planned and executed according to the flight plan. A clear weather was determined and chosen. The UAV was flown on the day. A very true planning for data acquisition is needed in order to avoid the problem of loss and cost. A flight planning shows a flight map which consists of waypoint on a topography map showing the starting and ending point of each line. Therefore, the flight planning includes the location of study area, flight altitude and speed, flight estimate time of the study, and important details of the flights. The flying height was set up to 50 meters above the ground and overlapping was set up to 70% side lap and 60% of end lap. A higher altitude will result object far in distance, meanwhile shorter altitude to the ground is not suitable. The total number of flight stripes is 7 stripes and the flight took about 5 minutes. The study area for data acquisition involved was the rooftop of T06 building. Ground data in this study was collected by using geodetic laser scanner as it has the advantage of geodetic positioning in the instrument. GLS is a type of terrestrial laser scanner that allows traversing. By using GLS, it's easy to position the laser scanner by inserting the known coordinates of the points and collect the point clouds of the building. Laser scanner was used to collect point clouds of etc facade of the building. One of the limitations using laser scanner is it cannot collect the surface of roof of the study area. Data acquisition using Topcon Geodetic Laser Scanner 2000 was carried out in a study by applying traversing technique. The laser scanner was located off each of the GSCP collected earlier, in addition few points on the ground to complete the traverse done by the laser scanner. Traversing technique means it has backside station and a front station instrument occupied on the current station. This occupied station of laser scanner and backside station must be set up on the point which has been obtained from the traverse GPS survey for the direct approach. Firstly, the laser scanner Topcon GLS 2000 need to be set up on a tripod and followed by leveling and centering the instrument. This step is important because the instrument must be leveled up correctly and plumbed directly on the station of point of ground in order to minimize the error in measurement. After setting up the laser scanner, bearing of coordinates of the back station were set in order to define force station. The line of sight of both back station and force station will with the
The next one is planning of work. So, data source for 3D mapping landscape. The data source of T06 UTM is required in order to create this map, or the digital train model is the most important element in creating this map. In DTM, the information such as maps topography is stored in the DTM, and DTM is also the base layer on which all features is placed. In order to get this DTM, UAV is used to create a high quality image to produce the digital train model. The next one is creating 3D model issues. There is so many issues that need to be tackled in order to create this map. So the first one is geographical area of the map. The size of the urban map is important, whether it is in a large area or in a small area, and how many buildings are there approximately. So these issues need to be solved before creating the map. The second one is scale of map. The scale of map produced play a really big role in the final outcome. This is because of it will affect the building models in the map. So the scale need to be chosen wisely. And the last one is accuracy. The importance of accuracy is the building location, size, and appearance need to be classified. This is because of not all buildings need to be included in the map for good. And the last one is building 3D model. For building this 3D model, there is so many software that can be used. But if there is too many buildings that need to be constructed or need to be created, the leveraging automation will likely to be critical. So the approach is specific software package need to use will greatly depending on the level of detail, or L or D desired, and the quality of the input data set. After done constructing the building, the models can be stored and maintained in the KML format. The other option to store the building model, a catalog can also be used. The features such as building's location, footprint, height, number of floor, roof characteristic, and the windows will often included and will be maintained in the catalog.
So now we move to the process of works. For UAV can be used for remote sensing, photogrammetry, and surveying. Optical cameras, thermal images, radar, LiDAR, and many other types of camera and sensors can be placed on board an UAV, and along with a navigation system, geographic data can be obtained. The captured data can then be used, for example, classification, image interpretation, photogrammetry, surveying. Remote sensing refers to technologies, commonly instruments or sensors mounted on aircraft or Earth orbiting spacecraft, for recording electromagnetic energy that emanates from areas of object o- on or in the Earth's land surface, ocean, or atmosphere, which provide a way to identify, delineate, and distinguish between them. The data are geospatial in nature, meaning that the observed area and object are referenced according to their geographic location in a geographic coordinate system. Then, all the data and images from UAV will be processed in Agisoft Metashape. Agisoft Metashape allows automatic generation of dense point clouds, texture polygonal models, georeference through automosite and digital model surface (DSM) from still images. Based on the state-of-the-art technology developed by Agisoft, it allows for very fast processing, providing at the same time highly accurate result, up to 3 cm of accuracy for area photograph and up to 1 mm for close-range photography. Agisoft Metasheet is capable of processing of thousands of photos, yet all the operations are performed locally without the need to transmit any data outside of the urban areas. This made of Agisoft an ideal solution for sensitive data processing. The software package has a linear project-based workflow that is intuitive and can be easily mastered even by a non-specialist. Professional photogrammetrists have the complete control over the result accuracy, thanks to a detailed report that is generated at the end of processing. When planning a laser scanning survey, the subsequent position of the scanner must be carefully chosen such that sufficient overlap of the point cloud is ensured. Also important are good visibility of the object in the scene and absence of pedestrian, vehicles, animal, and other temporary obstruction, as well as overhang, trees, and other occluding objects. These are the main cause of data voids. The scanning interval in horizontal and vertical direction should be equivalent and small enough to allow for capturing all desired details. The scanning interval is determined by setting an angular value. How much this interval is in centimeters depends on the distance oriented of the laser sensor with respect to the object. There is a strong relationship between level of detail or scale, scanning interval, precision, and object size. In the table, scanning interval and precision are set equal because according to heritage specification, scanning interval should be equal to or less than precision. When photo texturing of the final 3D model is required, a camera should capture the scene along with the laser scanner. A built-in camera allows automatic texturing of the 3D model. Since the orientation parameter with respect to the scanner are precisely known, however, when the camera is external, each image has to be linked to the corresponding point cloud using manually selected tie points. Proper photo texturing requires avoidance of over or under exposition and occurrence of shadows. The radiometric characteristics of the images should also be carefully balanced, and their spatial resolution better than the scanning interval of the laser scanner. Next, all the data from the terrestrial laser scanner will be transferred and processed in Regal Terrestrial 3D Laser Scanner System. Regal Terrestrial Laser Scanner provide detailed and highly accurate 3D data rapidly and efficiently. Applications are wide-ranging, including topography, mining, as-built surveying, architecture, archaeology, monitoring, civil engineering, and city modeling. All Regal Terrestrial Laser Scanner are rugged and fully portable instruments, tested under strict conditions for a reliable performance even under highly demanding environmental conditions.
So we will proceed with process of data. There's 4 process of data from GCP processing to UAV image processing to terrestrial laser scanning processing and finally point cloud integration. So we will take a look one by one. Number one is GCP processing. The crude information gathered from GPS is prepared utilizing the programming Trimble Total Control or TTC distributed by Trimble Inc. TTC gives geodetic control capacity in addition to handling what's more apparatus to empower GPS information to be prepared with investigation and reports. Next process is UAV image processing. The aeronautical picture information got from UAV will experience not many handling vectors before the creation of the orthophoto and the age of point mist. The handling programming that was used to create those final results in P4D MacBook Pro, the handling step will incorporate the underlying preparing, point cloud and work edge, and last is DSM, automatic or orthophoto edge. Number 3 is ground data processing, which is TLS processing. The information experience barely any means comprised of information bringing in, information enlistment and information cleaning. Figure underneath show that means of handling the 3D point cloud correct from TLS. Finally, is point cloud integration. After the entirety of the airborne information and the ground information has been handled, every one of them produce a set of information of point miss, and that point will be utilized to converge into one layer. So as to combine, it is extremely essential to ensure from the beginning that both of the point miss informational index were in a similar arranged framework.
Accuracy and analysis. T06 is situated in a flat terrain surrounded by some forests. To create the 3D urban plan, visual analysis is the most important application based on 3D model. Every user will have a different observation in the 3D map because of the eye level and the angle of view is different from every person. The output of the map may not vary with the actual condition of the area, such as the color of building, due to the distortion caused by the weather when the picture is taken. Aerial picture is taken by using UAV and 3D software. It's used to process the information, which is software is called Agisoft Metashape. High technology camera is installed inside the UAV, so accuracy is not a problem for the orthophoto produced. 2 to 3 hours is needed for the terrestrial laser scanner for the scanning session of the selected area, which is T06. The GPS quality is reduced due to low visible towards the satellites. In order to get a precise coordinate of the building, the vehicle that brings the terrestrial laser scanner is moving slowly around the area to get the coordinate of the building. This is why 2 to 3 hours is needed because the vehicle is moving very slowly to get the accuracy, to get a high accuracy. Overall, this map can be considered as accurate because of the equipment used is well calibrated and have a high technology. Thank you.
Now it's time for conclusion and recommendation. Many urban or environmental plans are defined with the object of helping practitioners and stakeholders in their decision-making processes. Those plans, particularly 3D urban plans, are increasingly used in different cities and countries for an intended wide range of application beyond mere visualization. Indeed, unlike map and drawings, 3D visualization reflects a view of the environment that a lot of people are familiar with and act as a communication tool. Non-geometrical data such as social history or acoustic data or statistic, for example, can be associated to urban geometrical objects such as buildings or streets that can be presented and visualized in 3D, leading to a localization as well as a better understanding of this data. By associating a domain, energy consumption, air quality to these 3D plans, we obtain richer 3D representation that can be used for simulation and reasoning. For recommendation, the application of UAV is able to become an alternative in creating an orthophoto map, which is much more economical and time-saving way that will lead in producing the urban 3D plan. The generation of the orthophoto map of T06 UTM areas successfully attained the objective because eventually the orthophoto map of T06 UTM area has been generated and benefits the user. The output can bring many advantages not only for visual use but also provide benefit in other future planning and development. Also, the application of terrestrial laser scanning allows to perform accurate evaluation of the terrain condition in T06 UTM area as well as in the anthropogenically transformed ones such as buildings and roads, embankments and cuttings. The area of T06 UTM's processes may be accurately located by means of control measurements. The adopted method allows rapid assessment of the intensity of these processes and the calculation of the urban material volume. In comparison with the traditional method, field measurements are relatively quick and easy to conduct. The methodology has another important advantage. It is possible to identify precisely the T06 UTM area. Changing the scanner coordinate system to the object one increases the accuracy of determining the T06 UTM area.